All right, today we're going to learn about alcohols. Should be fun. So alcohols contain a hydroxyl group, which is just a branch of OH. It's a functional group for alcohols. So here's the two most simple examples, methanol and ethanol. So you'll notice one carbon, it's like methane. For alcohols, they end in OL. All right. Just to give you an idea, methanol, if you drink a little bit of that, you go blind. Ethanol, you drink a little bit of that, you probably know what happens. Okay, so sometimes ethanol is called grain alcohol. It is what's put into alcoholic drinks. Methanol is sometimes called wood alcohol. It might be used in chemical products. Nothing you ever want to drink. All right, so I already mentioned alcohols are named by using the OL suffix, but if more than one configuration is possible, you need to put the location of the hydroxyl group before the suffix. I'm going to show you exactly how to do that. You number the carbon atoms starting from the side of the parent chain closest to that hydroxyl branch. Okay, so check it out. I've got propane here with a hydroxyl group. So I got to number it starting from the side with the hydroxyl. It's located at carbon 1, so you write propan 1-ol. So you drop the E, put the number, and it ends in ol. Okay. If the hydroxyl was here, that would be propan 2-ol. Okay, branches are also possible here. So we got 4 in the parent chain. That makes it some kind of butanol. I number from the side closest to the hydroxyl. Okay, so 1, 2, 3, 4. The hydroxyl's on carbon 2, so it's butan 2-ol. And there's a methyl at 3. So 3-methyl butan 2-ol. Okay, I got to tell you this. If you have benzene with a hydroxyl, so it's alcohol formed by benzene, it's called phenol. It's not called benzol. Remember, phenol is when this is the branch. So just keep this PHEN prefix in mind. It's used for branches of benzene as well as the alcohol of benzene. You might see this once or twice. I'm certainly not going to try to fool you on that. All right, moving along. So there are polyalcohols. You're not going to see too many of these, but I got to tell you about it. They contain more than one hydroxyl. Here's how you name them. Okay, I actually messed it up once already. So this is ethane with 2 carbons, but there are 2 hydroxyls. Okay, that makes it a diol. So you bring the prefix back when there's more than one branch. That hasn't changed. The way you name them is a little strange though. So you bring the E back. It's not ethanol, it's ethane, diol, but you got to tell me where it is. So before the suffix, you put the location. So this is ethane 1,2-diol. Notice you could have ethane 1,1-diol. I'm only going to ask you 1 or 2 of these. This is not a big deal in the course, but I do have to show you how to do that. Okay, so again, you bring the name back, ethane. There's 2 hydroxyls, so it's diol, and then you put the location in front. Let's take a look at this one. So 1, 2, 3, 4. This is butane. It's another diol, and it's going to be at 2, 3. Okay. Last thing from alcohols before we get into a type of reaction is the degree. And this confuses people. The degree of an alcohol has nothing to do with how many hydroxyls there are. Okay? It's how many carbon atoms the hydroxyl bonded carbon atom is bonded to. That's confusing, but I'm going to show you every possibility here. Okay? So a first degree alcohol looks like this. The hydroxyl is at the end of the parent chain. Okay, so that's a first degree. Sometimes you write it like this, 1 degree alcohol. Okay, so if you read the description again, how many other carbon atoms the hydroxyl is bonded to? The hydroxyl carrying carbon. So this carbon has the hydroxyl. It's bonded to 1 other carbon. That makes it first degree. Okay, let's look at a second degree. So here's my carbon with the hydroxyl. It is bonded to 2 other carbons. This is when the hydroxyl is in the middle of the parent chain. It doesn't have to be exactly in the middle, just not at the ends. Okay, so that's a 2nd degree. Sometimes you write 2-degree alcohol. All right, you don't see too many 3rd degrees, but here's what it's going to look like. The hydroxyl's in the middle, and the carbon that has the hydroxyl also has a branch. Okay, so 3rd degree alcohols are super rare. So it's hydroxyl in the middle, and it shares its carbon with a branch. I don't think you should memorize these. I just wanted to show you the possibilities. Just know what degree means. It has nothing to do with how many hydroxyl groups there are. It has to do with how many other carbon atoms the hydroxyl carrying carbon atom is bonded to. So if it's on the end of a chain, it's only bonded to 1 other carbon. If it's in the middle, it's bonded to 2 other carbons. If it's in the middle and has a branch from it, it's bonded to 3 other carbons. Those are the only possibilities.